Hello, everyone. My name is Jose Betancourt. I am part of SUSE's Technology Partners organization, and welcome to the Best Practices for HPC in the Cloud session. How to rationalize your HPC infrastructure by leveraging the public cloud. Let's discuss the agenda for a second. The flow of this presentation is as follows. First, we're going to discuss the current state of high-performance computing in the cloud today. We're also going to establish the requirements for today's high-performance computing environment. Next, we're going to rationalize that use case for high-performance computing in the cloud. Last but certainly not least, we're going to discuss how to leverage the SUSE ecosystem and potential next steps in your HPC journey to the cloud. So without further ado, let's just get started. Once upon a time, HPC was the reserve of university and government research labs. But now they become crucial parts of enterprise infrastructure. And enterprises today no longer need to invest in HPC hardware either, with HPC in the cloud becoming increasingly common. In fact, according to Hyperion Research, over 70% of HPC sites run some jobs in public clouds, and that's up from only 13% in 2011. And they also have a very high return on investment, with $458 of new revenue per every dollar invested and a profit of $58 per every dollar invested. Now, before we start delving into the requirements portion, let's establish some base definitions to help frame the conversation. Because normally people just have one idea of high performance computing, and I think we can build it along two types of needs. According to the US National Institute for Computational Sciences, high performance computing, or HPC, is the application of supercomputers to computational problems that are either too large for standard computers or that would take too long. Given today's business requirements and the use cases, that definition is broad enough to address two types of computing needs. The first one is what we probably are most used to as HPC, or parallel computing. In parallel computing, for HPC systems, everything is split into smaller programs called threads. Each thread corresponds to a core, and then to piece a larger program together, the cores need to be able to communicate with each other efficiently, and the system as a whole has to be organized for that. Another way of viewing HPC, or high performance computing, is what's commonly referred to as parallel for capability. Let's use large scale weather simulation as an example. You have multiple servers that are needed to work together to hold the grid data in memory. These servers need to communicate and synchronize work over the grid, and communication between the servers can become a bottleneck. That's what we commonly know as high-performance computing. There is another use case called high-throughput computing. High-throughput computing is focused on the efficient execution of a large number of loosely coupled tasks. High-throughput systems usually execute as independent, sequential jobs that can be individually scheduled on many different computing resources. With high-throughput computing, users can run many copies of their software simultaneously across many different computers. High throughput computing can be seen as parallel for capacity. An example of it would be web engine search. You have multiple servers holding different pages. Each server can report the result of each individual search, and the more servers you add, the quicker the search is. The reality is that in today's environment, we have users that need access to both traditional high-performance computing and high-throughput computing infrastructure for them to do their jobs. It can be instances where high-throughput computing may be generating the base data that then high-performance computing will analyze. Just look at the verticals where HPC and high-throughput computing address new solutions. Now, from a cost perspective, though, acquisition and maintenance of these large infrastructures, when you measure them against the actual time that they're used, can be cost prohibitive. And that's where the cloud brings the cost benefit. The on-demand nature of the computer environment, and combined with the availability of what they call spot instant pricing, makes the cloud an ideal environment for high performance computing and high throughput computing from a cost perspective. The rest of this presentation focuses now in establishing the requirements and guidelines that would lead to a successful implementation of HPC and high throughput computing workloads in the cloud. Now that we understand the market relevance of our discussion and that we introduced the concept and the definition of HPC and high throughput computing, let's drive more detail and establish the requirements for today's HPC environment. The drive to the cloud for HPC and high throughput computing comes with a common set of customer pain points and challenges. The HPC environments are notoriously complex. Think of the paradigm of now managing high performance computing and high throughput infrastructure. And don't forget to handle the growth in data and how it impacts overall data management requirements. We have time to solution. How quickly can you design, build, and deploy the infrastructure required to meet the workload requirements? And then maintenance. When it comes to maintenance, we have to think of the entire stack. Major upgrades drive the need to recertify all the components that make up the stack. And let's not forget that as you add more vendors to that stack, the more challenging the ongoing support becomes. And last but not least, there's the cost element. Building and maintaining infrastructure is expensive, and in many instances, it is not part of the core business. There are capital expenses if you're dealing on-premise for hardware, and you're talking about compute, storage, and networking, as well as any property, plant, or equipment that may be required. So if part of this new implementation requires a new building or new HVAC, that should be part of the cost for the on-premise solution. And then there are the operational costs, such as ongoing power and cooling for the compute infrastructure. Given those pain points and the challenges that we already discussed, let's establish two criteria that are easily understood and accepted by management and the technical guys alike. When it comes to any technology solution, there are two key measures: time and cost. So when it comes to time, let's talk about time to solution, which basically means how soon can the business have the application environment working, addressing its requirements, and helping the enterprise with its core business. And then the cost to solution, which could also be called the cost of solution. Basically, how much is this really going to cost me? So it has to encompass all capital and operational expenses that are part of any major project. The time and cost solution criteria is applicable whether you're in business, academia, or government. The slide that you're seeing now is an illustration of what it takes to take and build and deploy a new application or workload. The cycle itself is pretty much whether the payload is deployed on-premise or in the cloud. But for illustration purposes, we changed the color of the three processes that will probably benefit the most from a shift to the cloud. The first three portions in green are the requirements pillar. We convert the business requirements into a specification document, and in turn, we build a solution design or solution model. The next three steps are where we believe cloud computing can make a major impact. At the solution platform selection stage, we now have choices for different service delivery models: infrastructure as a service, platform as a service, and software as a service. Furthermore, with the cloud, you have the ability to select platforms that are optimized for high throughput computing or high performance computing. You no longer are in the difficult position of trying to select a high performance computing platform and then trying to shoehorn a high throughput compute workload on it. Once you select the platform, you may want to go back and review the original solution design. For example, a review of the service delivery options may lead to a different solution model that the one originally envisioned. Also, this is the right stage to plan a data transfer strategy as well as discussing whether the new environment will be managed as part of an integrated solution, basically combining on-cloud and on-prem as a hybrid, or if you're basically going to treat them as two distinct application environments. Under the acquisition process stage, the environment can be made available at the swipe of a credit card, debit, or PO, depending on the cloud provider and depending on your requirements. When it comes to platform implementation, you're skipping the number of days or weeks that you need to order the equipment, for the equipment to arrive, and then to set up in your data center or computer room. A test environment in particular, with different configuration options, can be ready in hours, if not minutes, depending on the complexity of the desired test. Lastly, as you move the implementation and to the evaluation stage, note that the evaluation results may trigger changes to the platform implementation. A major advantage of the cloud is the ability to make these changes quickly and not be left standing with misconfigured hardware. So now that we made a compelling case for HPC and high-throughput computing in the cloud from a time and a cost perspective, let's look at how to rationalize the use case for HPC and high-throughput cloud deployments through a checklist. From an IT leadership perspective, the benefits of cloud computing, primarily its elasticity, are very enticing. However, IT also needs to plan and tackle potential integration challenges. Looking at these integration challenges, let's convert them into a powerful checklist. For example, some workloads are more suitable to be migrated to the cloud than others. So take the time, profile the application workloads based on resource usage and parallelism. High-throughput computing workloads are easier to deploy to the cloud. They're more cloud-friendly. While cloud elasticity can bring financial benefits, you have significant CapEx reduction or elimination, good OpEx or operational expense management practices require good cost control practices, including the evaluation of existing software licensing based on workload usage. The cloud brings a variety of options in terms of service delivery models, as we previously discussed: infrastructure as a service, platform as a service, or software as a service. On top of that, different cloud providers have different capabilities. So spend the time testing the different options available that meet your requirement specification and fit the solution design model. Don't jump into the first option. Take the time and test. Usability of the HPC or HTC cloud environment is key, particularly in your first workload deployment, probably even more so. Implementers need to decide whether the benefits of running the hybrid environment using middleware outweighs the complexity of the setup. And then last but not least, use some of the new technologies available through cloud providers to tackle the I/O requirements. Examples, for example, in AWS, there's Weka.io, and Lustre and BGFS are available through Azure. So now that we discussed the rationalization of the use case by the means of a checklist for a successful cloud-based delivery, let's take a look at some of the benefits that SUSE brings with SUSE Linux Enterprise for high-performance computing. The fundamental block for SUSE is SUSE Linux Enterprise for high-performance computing. SUSE Linux Enterprise high-performance computing is a highly scalable, high-performance open-source OS designed to utilize the power of parallel computing for modeling, simulation, and advanced analytics. SUSE Linux Enterprise high-performance computing supports a number of HPC services and capabilities that include but are not limited to workload management in the form of Slurm, remote and parallel shells, performance monitoring and measuring tools, a scalable profiling library for MPI, message passing interface applications, scientific and mathematical computing libraries for parallel computing, as well as console access and management. The product is available for both x86 and ARM platforms with enterprise class support. We deliver a higher portion of the system stack under one vendor to provide simplified support Remember back when I mentioned the value of the stack and the complexities associated with having multiple vendors in the stack. What SUSE is delivering is a larger portion of the OS stack under one support umbrella. Now, high-performance computing fuels the new generation of data-intensive applications, including artificial intelligence, machine learning, and advanced analytics. These applications require both high performance and extreme scalability to produce timely results. With SUSE Linux Enterprise High-Performance Computing in the cloud, you get the flexibility to scale your process-intensive enterprise applications quickly and easily while controlling costs. Now, cloud-based HPC applications can scale to thousands of compute cores, and they can extend on-premise big compute by extending it to the cloud, or you can run natively as a 100% cloud-native solution. Since this is a presentation on the benefits of HPC in the cloud, let's discuss some benefits of one of the major cloud offerings and a key partner for SUSE, which is Microsoft's Azure platform. So using Azure as an example, Azure supports RDMA, Remote Direct Memory Access, and that enables scientists and engineers to solve complex problems by using simulations running on Azure. RDMA technology is enabling all versions of SUSE Linux Enterprise HPC images on Azure, and it enables direct communication through the InfiniBand network. This helps faster communication between the different virtual machines at low latency for parallel workloads and applications that take advantage of the MPI or Message Passing Interface stack. Azure also brings a couple of interesting other tidbits that I want to bring up. The hybrid HPC pack. So many HPC users start with hybrid models and then grow to native cloud deployments. The hybrid HPC pack from Azure allows a head node to be configured on-premise and then distribute jobs to Azure compute nodes. This model can be used for large workloads to scale very quickly, as well as to minimize the cost so that fewer nodes have to be purchased for on-premise use. The Azure Resource Manager allows the creation of templates that span multiple Azure services to automate deployment, configuration, and monitoring. Resource Manager is a key component of any HPC deployment on Azure and ensures consistency in deployed instances and monitors any failed resources that require reprovisioning. And GPU instances, graphical processing units or GPUs, provide very large core count processors for execution of certain workloads in parallel. Many workloads can benefit from GPU acceleration. To assist these workloads, Microsoft provides GPU-optimized instances on Azure. So we're almost now at the end of our presentation. Let's review what we discussed so far. First, high performance and high throughput computing has successfully escaped from the lab, and they are now part of today's enterprise. We also discussed how this is not a matter of high performance or high throughput, but of high performance and high throughput computing. Second, we established the customer pain points and challenges. We also identify how cloud computing can help reduce time and cost to solution. Third and final, we introduced SUSE Linux Enterprise High-Performance Computing, as well as some interesting technologies available via Azure that can be leveraged while implementing your HPC or high-throughput computing solution. It is often said that the longest journey begins with a single step. As you look to deploy high-performance and high-throughput computing environments into the public cloud, please remember, scope your projects and or initiatives properly. The initiative needs to have a beginning and an end. And once you know what the end picture is, work out the details such as applications lists and dependencies, application profiles, licensing, and growth requirements. And don't forget to track the cost of the on-premise infrastructure that will be replaced or an estimate if not purchased for a new project. Analyze. As you look at applications to move to the cloud, complete a workload profile to see if the application is cloud-friendly based on resource consumption and degrees of parallelism. Establish a profile in terms of CPU, GPU, memory, network, and storage for the target workloads. Compare with what's available from the different cloud providers. Also, Analyze the workload licensing requirements versus cloud-based licensing requirements, and build the requirement specification based on the scope and analysis. Test and test and test. As you complete the scope and analysis section, you will have to address what service delivery models meet your requirements and a list of CSP or cloud service provider finalists that meet your requirements. It's all about testing. The low cost to build and deploy test environments enables you, the customer, to test all your deployment and usage scenarios, as well as perform a cost analysis of each option. And lastly, deployment. Some key items to remember. Determine your middleware management choice. Are you aiming for an integrated environment, or will you treat the on-prem and cloud environments as distinct environments? There are pros and cons to each option. Let your requirements drive your choice. Also, start with the easier high-throughput workloads that enable you to achieve the benefits of cloud computing faster, while your staff gains the necessary experience to operate and manage the new environments. And analyze your actual results against your estimates. If there are any major discrepancies, identify the cause and come up with a plan to address before proceeding with the rest of the migration. And that's the end of our presentation. Some live links in the presentation for further review material on the 3 major cloud platforms for high-performance computing, as well as SUSE Linux Enterprise high-performance computing. Thank you for your time. Have a great day.